I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. Peace! Peace! Amen.
Ladies and gentlemen, welcome to Job Shop USA. My name is Keith, and we're in here at my shop. Now, we're all set up here. We're center line with our part, and we come over and we touched it, and we're ready to take a skim. We're just going to take a little bit off the bottom here, just to make a nice, good, clean bottom, and then we're going to give it a relief on each side so that it'll set down into the T-slot on the grinder over there. To get to this point and have this part already cut out by the WAZER was pretty cool. It was a little under an hour and less than $14 cost to actually cut that out, and it did it by itself. I had no issues with it. So now we don't have to do all the milling of the different shapes, and we don't even have a mess to clean up to get to this point here. All right, now let's go ahead and we'll start cutting. It's been a while since we've had a mister on a mill there, so we brought the mister we had over on our two-post grinder on the Rutland there. We brought it over here, and we made the one pass here, and we use just a Lumitap on that. That's our go-to lubricant. So we're just going to add on a little bit of mist here. And we're going to be going down each side. We figured 5/8 was the direction we needed to go each way to make the half inch. Oh, we're going to take it 25 thousandths over for right now, and we're going to give it 200 on the depth. This should at least keep the chip clean and clear. The coolant, we're going to see what we need to reprimand the coolant, whether we put some absorbent pigs up here or we let it go all the way into the bed and suck it up from there. Any kind of coolant you're using keeps the part cool, the tool cool, and lubricates the cut itself, and you usually always get a glossy finish. All right, I got both sides of the key to the right width, and I decided to go ahead and take half of the depth away because I needed to bring the part or the whole jig down a little bit. We still might be facing a little bit off the top of the top side, but I want to at least have the combination of having the location in the groove, but enough clearance for a T-nut slot to come up into that slot from the bottom sides. We're going to go ahead and put the clearance for a 3/8 hole for our 2 hold down bolts. About 3 1/4 on center here. Just a dimension we happen to be shooting for, that's all. It's not critical. All right. We'll go ahead and we'll break those holes there. All right. Deburr the sides here. All right. Ready for the next step? Let's check our fit here. Move the ball down there. Okay. Now, height-wise, we're still too high. So I've got to take some off of the top and do the bore, which is no biggie. You know, we gave ourselves extra material here. I like this. We're not going to even, I don't think we're going to need to spot face those, but we might set this up when we're over there doing the milling and this hole here. We'll come down and we'll spot face those for Allen bolts or something like that. We're going to slide in 2 flat bars. I think we've already got them. We have these already made for our rotary tables and stuff, and they're made to slide in these smaller slots, and that'll give me the 3/8 thread that I need to go into here and here. All right, so that's probably pretty much a given, and now we just need to figure out how much less we're gonna make this. All we need is ball to go up in there, and the ball is going to be soldered to a cylindrical, so it doesn't really, we're not going to be real critical. But if we went like that and we went like that, we're going to be, that's max on the height, and we might take another 1/4 inch from that. Okay. We'll be able to slip that thing right in and then drop it in with this thing in place. Awesome. We drilled in here half an inch, half-inch diameter, down 2 3/4, and now we're just chasing it down here with a 23/32 here. I don't have a reamer, but I do have a really long 3/4 4-flute end mill. And I'm going to engage my quill so that I can hand feed it down. All right, let's give it a bit of try. It's a 1/2 inch of depth now. One inch of depth. Oh, I lost all my bristles. Inch and a half. Feels like I'm getting at the bottom here now. Like 2/400. All right, I'm gonna come on up. I gotta get a mirror so I can look in there. Okay, with the mirror, I can see that I still got more to go down. Okay, right there's where we were at. And give it plenty of juice down in there. We were at the 1/2 inch diameter, but the 3/4 diameter was a little shy, so we know that we did take the first one all the way down to 2 3/4. We just went by 2 600. All right, there's 2 700. There's 750. And we'll call that it. That was the difference between the 3/4 and the 1/2 inch, which was the 1/8 inch there. Okay, we're gonna look in here again. Now we gotta blow it out. Pretty good. We've still got a little bit more in the center there, but I'm kind of liking that depth. While we have this tool in here and we're set up on 0, we can come out to each side of these. We don't know how close they are in relationship to splitting this on here, but we're going to go ahead. We eyeball everything together and kind of put everything together here. I'm going to say we're pretty symmetrical within about 5 thousandths or so. So let's just take half of that 3 1/4, which would be like 1 5/8, right? Let's see, 625, right there, give or take a thou, and that actually looks like it's pretty equal to that side there. So let's just touch down and make a nice flat spot there. That looks good. Okay, what are we at? We'll set 0 there just so we put the other one the same height. Okay. And there we go, 625. Looks pretty good. Looks like the same on the other side here. Another 20 thousandths on the depth here. And there we go. All right, at least we got 2 spot faces on there. That bore's done. All right, we're going to make our spring-loaded piece here, and then after we have it, then we're going to decide what we're going to do for a plunger here. We want to have a finger control to release our ball to rotate an index. I don't want to drop that ball in there, but that ball is 3/4. Let's just go ahead. We'll take this is a Niagara end mill here, and okay, I say we've got a good fit there. Okay, that's what I'm looking for. All right, now we're going to go ahead and get ourselves a nice piece of 3/4 stock, and we're going to put a center drill or a countersink in one end of it that we can solder the ball to it, and we need a hole down in through the bottom of it so that the spring has room to travel. Since we pulled this out of the mill, I've just radiused these edges right here, and then we did lap it again. Let me see if I can do that. There you go. Looking down the board, just a little tiny drill point, but the rest of it's square on the bottom. And there's our holes coming out. All right, locates right down in there. We went over to the Rutland now, and we turned a little barrel, 1/2 inch all the way through, and then just a relief for the spring on this end, about a 1/2 inch deep. It'll have an inch of travel completely. This actually compresses almost to 3/8 of an inch. All right, so that's going to go down in there. It's going to be spring plungered. This is the ball that's going to get silver soldered to the top. We just roughly took one of our T-nuts that we're going to be putting down in there, minus the T part. What we have is about 200 thousandths right over the top of this, so we know the height. We measured the bore. This is like 2,900. 2,900. We measure this overall height right now, 4 inches, 24 thousandths. So we've got to take 900 thousandths off of this thing. So we're going to go put it in the lathe. We'll part off 900 thousandths, repress that. We'll come over here and we'll assemble, and we'll make sure that everything can move in here Looks a little shorter, huh? Let's see what we got here. We're looking at like 3/100 or something like that. 39995. All right. When I was over there, I actually adjusted in the extra 25 thousandths or whatever. All right. So now let's put our spring in here, our ball. We'll just take and pop this out for right now. Pop that down in there. I love that fit on that. That's so great. Okay. Because this isn't in there and I can't lock it all the way down in here, I just want to make sure that. Okay. I've got to take just a tiny bit more. All right. I just kind of eyeballed a few thousands on here. Let's just see what we did come down here. 3 inches 38. So I took about 50 thousandths off of where we're at. There we go. I really wouldn't need to do anything else, I don't think. All right, I redecided. Hey, what? The guys can't change their mind either? All right. Um, I really do like the way this feels and how positive that is. And also, too, now I really see that I have access for this surface up here. And also, too, I'll be holding this flat here, perfectly flat, and the flat on the other side if I have to kiss the sides of these splines here. Um, and I got good straight down. The grinding wheel coming straight down on there is actually clearance of like a 16th of an inch on the side of the next flute there. So I'm all good there. What I'm going to do is I'm going to silver solder that ball to the plunger. I'm going to do that part because I want to make sure that it stays perfectly in center and in line and it's rigid as possible. When these two are bolted down 100%, I'm not going to have the tendency of the top wanting to like, but that's because there is nothing holding this down right now. All right, so I'm going to go silver solder that ball there, and then I'm going to take this apart so that I can get my two threaded keepers down in there and two bolts and holding this thing down tight. Then we're going to give it another test. I silver soldered the ball to the top of the tube, and then I spun it in the lathe just to clean the flux and whatnot off of where it needed to be. Cleaned out the inside there, lightly oiled it. All right, let's put the shaft in here and give it a test. Hey, I think it does take force to turn this thing, so and it doesn't rock. Once it's in there, it does not rock. So our indicator or our positioner is complete. Now we need to go ahead and make up a bar to sweep our radius into the cutter. We could borrow or procure uh, angles and radius cutter or dresser for this, but this way here, If we make a bar with our dress at that diameter, we can grind on here, and if we wanted to freshen up the wheel, we could just pop this shaft out, pop in the dummy with that bit in there, and dress it right in place without pulling any of our setup out of here. You know, that was fairly painless. Pretty simple little gadget. Actually, more simple than I had in my design originally. That's the way it goes sometimes. You luck out. All right, I'm going to get my wheel spinning on the wheel dresser. That will let me just pop out the shaft, pop in the dresser, and dress the wheel in between cuts if I want to. It'll get the radius we want in the stone that we set up, and we can get sparking on this shaft here. All right, thanks for visiting Job Shop USA. Get her done.